Hey guys, welcome back to our notes 8-2 example 3. We are dividing and we are assuming that all expressions are defined. So we do not need to find when our x values are undefined. So in part A, we just want to review how do we divide by two rational expressions when they're just numbers. So some of you might remember that when we are dividing by a fraction, we're really just multiplying by its reciprocal. So any division of a rational function is really just a multiplication question. So now we've turned it into a problem just like our previous examples. So when we're multiplying fractions, multiply our numerators. 9 times 2 is 18. Our denominator, 3 times 4 is 12. So to simplify this, my GCF is 6. 6 times 3 over 6 times 2, my 6 is canceled. So this simplifies to be 3 over 2. So in example B here, now I have 4x cubed over 9x squared y divided by 16 over 9y to the fifth. So this becomes 4x to the third over 9x squared y multiplied by the reciprocal. So I'm going to multiply my numerators to get one numerator. 4 times 9 is 36, x to the third, y to the fifth. 9 times 16, let me just double check that, is 144, x squared, y. And so I know that I can factor out a 36 x squared, and that will leave, x squared y. Because the GCF of 36 and 144 is 36. The GCF of x squared and x cubed is x squared. And the GCF of y and y to the fifth is y. And so that's going to leave y to the fourth. And if I factor out that same GCF on the denominator, that leaves 4. And so the 36, the x squared, and the y's cancel out. So I'm left with y to the fourth over 4. So now in part C, we have an elaborate division problem. Let's have fun with this one. So first, we know that it is changing into multiplication by the reciprocal. So this is really x to the fourth minus 9x squared over x squared minus 4x plus 3 multiplied by x squared minus 16 over x to the fourth plus 2x cubed minus 8x squared. So now let's factor and multiply. So this numerator, first I'm going to have a GCF here of x squared. So if I factor out x squared, that's x squared times x squared minus 9. And then x squared minus 16 factors to be x minus 4, x plus 4 by difference of squares. So now this factor here, I'm looking for two numbers that multiply to make 3 and add to make negative 4, negative 3 and negative 1. So this is x minus 3, x minus 1. And then I see this here trinomial has a GCF of x squared, and that's going to leave x squared plus 2x minus 8. So I factored, but I could still factor this binomial and this trinomial some more. So first, x squared minus 9, I know is x plus 3, x minus 3 as a difference of squares. And then x minus 3, x minus 1, x squared. Now here I'm looking for two numbers that multiply to make negative 8 and add to make 2. That's 4 minus 2. So this is x plus 4, x minus 2. Okay. So now that we have factored everything completely, we can cancel out any pairs that we see on both the numerator and denominator. So the x squareds cancel. Let's see, x plus 4, x minus 3. I think that's it. So my final answer is x plus 3 times x minus 4 over x minus 1 over x minus 2. Simplified. All right, let's go on to our final examples.